Write a 8051C program to convert a packed BCD, the numbers 29H, to ASCII and display the bytes on P1 and P2. So you need to convert 29H, which is in packed BCD, to ASCII. So what is the logic behind this? So 29 is the packed BCD. Yes, you want to convert it to ASCII. So the corresponding ASCII will be 32 and 39. So how do you do this? This packed BCD, you will have to convert to unpacked BCD uh, with 02 and 09. So 29 you have to convert to 0209. Then you have to convert the 02 to 32 and 09 to 39. So how do you convert this 29 to 02 and 29 to 0, 29 to 02 and 29 to 09? So as per the logic, 29 can be converted to 09 by ANDing with, that is 29 and with 0f will give you what? 2 will be masked, so that will give you 09. And if 29 is AND with F0, then that will give you 20, all in hex. So this 20 you have to convert it to 0. Okay, so 20 you'll have to convert it to 02. Then 9 is already in 09. So you can just OR this with 30 to get 39. 20 you have to convert to 02 by shifting. Shifting, how do you shift it? Shift it to the right. Shifting to the right by how many positions? You can just imagine it, 20 to 02. So you have just 1 in this 20. And where is it? 0010 0000. You have to change that to 0000 0010. That is 0010 should be converted to 0000 So what is happening? This one should be shifted to this particular position. So how many positions should this one jump? 1, 2, 3, 4. So if you shift this entire number to the right by 4 positions, then you can make 20 to 02. Right? So that is the logic behind converting 20 to 02. Now after converting 20 to 02, what should we do next? You can just OR 02 with 30 to get 32. So what is the logic behind this ORing? So that is, you can see 02 0 2 or with 30. 0. So that will give you, so if you OR this, you will get 0 or 0 is 0, 0 or 0 is 0, 0 or 1 is 1, 0 or 1 is 1, 0 or 0 is 0, 0 or 0 is 0, 0 or 1 is 1, and 0 or 0 is 0. So what do you get? You get 30. So that is the logic behind converting 2 to 32. Same logic for converting 09 to 39. Right? So this is the logic behind this particular question. So how do you do this? I'll just paste the program. So your solution comes here. Okay, this is your solution. This is your program. So include a register, hash include register 51 dot hash void main void is common for everything. Then we'll come to the logic first, then we'll declare all the characters or all the variables. So what do you want? 29 to be converted to 32 and 39. So this particular thing, after the execution of this particular instruction, what happens? There is a variable called myByte which is declared as unsigned character, and that gets the value 29. 29 means 00101001. Okay. So why is it declared as unsigned character? Because it has a value of 29 only, which is less than FF. So in 8 bits you can represent this particular number. So you can very easily declare it as an unsigned character. Next, what did we do? This 29 should be separated as 02 and 09. So it's easy to separate it to 09. That's what we are doing first. That is x. What does x get? MyByte and 0f. MyByte and 0f means you'll get 09. 1001. Then we have already discussed the logic. That's why I'm just writing the answer. I'm not showing it. So x or 030, that is 30h. So what will you get? P1 will get the value 39h. Yes. Next, MyByte and F0 to get what? 20. So Y will get the value MyByte and F0. So that will give you the value 20h. Next, we discussed that this 20 should be shifted to the right by 4 positions so as to make it 02. So I'll just show you that in a single line. Okay. So the first step. So this 20 is what? 00100000. So this is what is the value of y at this particular instruction after the execution of this particular instruction. After that, what happens? Y is shifted once. It should be shifted 4 times. After shifting it once, what happens? 0001. That is, while shifting, the vacant spaces will be filled with zeros. So rest will be 0. That is the first shift. So I'm just after the first shift, I'm just putting a semicolon. It just means that I'm going to the next shift. Okay. It's not part of the syntax or anything because I've commented it. So this is just showing that after the first, this is the first shift. Second shift will be 0 0 0 0, then 1 0 0 0. So that is 2. Third shift 0 and 1 will be shifted. So you have a 0 there, 1, right? So this is 1 2 3. One more shift 0 0 0 0 0 0 1 0. So what is this? This is 0 to H. So this is 0 to H. So Y now gets the value 0 to H. Next, what do you do? I'll OR this with 30 so as to get 32. We showed how do you get the result of the OR operation. So here I get 32H. So as per the question, you needed to send the bytes to P1 and P2. So I have sent these bytes to P1 and P2, 39 and 32H. Next question is write a C program to convert ASCII digits 4 and 7 to packed BCD and display them on P1. So in the earlier case, packed BCD to ASCII. So now ASCII to packed BCD. So how do we have these? What is the logic behind this? We have 4 and 7 as the ASCII digits. So actually what do we have? We have 34 and 37. The hex equivalent of these ASCII digits will be 34 and 37. So 34 should be converted to 04 and 37 should be converted to 07. 34 should be converted to 04 and 37 should be converted to 07. So now what is happening? It becomes unpacked BCD. 04 and 07, they are called the unpacked BCD digits. Unpacked BCD, right? So ASCII to unpacked BCD. So after converting ASCII to unpacked BCD, now we have 04 and 07 in two variables. So 07 is okay. But 04 you want to make it as 40 and then only you can change combine these two 40 and 7 you can OR it to get 47. So how do you change 04 to 40? How did we change 20 to 02? By shifting to the right by 4 positions. So 04 is what? 04 is 0100. 0 before that. Okay. 00000100. So you want to make this as 40. So this 1 should be shifted to 0100. So 1, 2, 3, 4 position. So if you shift 04 to the left by 4 positions, then you can get 40. 707, you can just keep it like that. So convert this 04 to 40 by how? Shifting to the left by 4 positions. Then 40 or 0, 7. So what do you get? You'll get 47. And that 47, that OR operation can be done, and the result can be sent to P1. So this is the logic behind this. So that's the solution. So here we can see that W is given as 4. So you can see the quotes. So it is taken as ASCII. Is it equal to 7 in quotes? So 7 is also taken as ASCII. So the equivalent hex value will be for 34 and 37. Then W, I'm changing it to W and 0F. For what? For converting this to 04 and this to 07. After converting it to 04, I'm shifting it to the left by 4 positions so as to get 40. And then OR these two so that you get 47, and that is sent to P1. So write a C program to convert binary or hex to decimal and display the digits in P0, P1, P2. So why P0, P1, P2? Because it is FD, and FD is equivalent to 253. You can just check the value in decimal. So it is equivalent to 253. That is 15. F is 15. 15 into 16 plus D 13 into 16 raised to 0. That is 1. So that is 253 in decimal. So for that, what you do is you'll use the divided by and the modulus operators. So why the divided by operator? To give you the quotient, and modulus operator to give you the remainder. So if you divide FD by 10, what do you get as? That is FD, you know it is 253. So the quotient will be the equivalent of 25 in decimal, which is 19 in hex. You can just verify that. And the actual remainder is 25, 253 by 10 is, remainder will be 3. Okay. So FD modulus 10 will give you 3. FD divided by 10 will give you quotient as 25. So you have FD divided by 10 in a particular variable, which will give you 25, and FD modulus 10, which will give you the remainder 3. So 3 you got. Now you need 5 and 2. So how do you get 5? So you have 25 stored in a particular variable after the division process. So 25 I will again divide by 10, and you will get 2 as the quotient and 5 as the remainder. So if you give 25 modulus 10, then you'll get 5. So you got 3, you got 5. Now you just need 2. So how do you get 2? You will just take this operation, that is 25 by 10. So you'll get the quotient as 2. So this 2, this 5, and this 3 you will take. So the solution is this. So FD is your value which you want to convert. FD divide by 10. So what does x have? X is equal to, like we told, x has what? 25 in decimal. Okay, I'm not saying in hex. What will be stored in the in x, that particular position will be in hex only. That is, it will be stored in as 19 only. For ease of saying, like in division, it is easier to say in decimal. That's why I'm talking in decimal form. So the equivalent of 25 in decimal in hex, that will be stored as the value, that is 19. Then d1. So I have another variable d1. So what will d1 have? D1 will have win byte, that is fd modulus 10. So what is fd modulus 10? That is 3. Then I'm defining another variable d2. So what will d2 have? X modulus 10. What is x? X is 25. 25 modulus 10 is what? The remainder of 25 divided by 10. So that is 5. Then I have another variable d3. So what is d3? d3 is x divided by 10. That is 25 divided by 10. That is 2. So where do I have the values? Where do I have the digits? I have it in d3, d2 and d1. So I will send these values to P0, P1, P2. So that P0 will have d1, that is the lower order digit. P1 will have d2, the middle digit, and P2 will have d3, the most significant digit. So this is the conversion of ASCII to packed, packed BCD to ASCII, and binary to decimal or hex to decimal data conversions.